All right, so the last thing we did was a couple of examples taking points from rectangular to polar, polar to rectangular. Now we're going to look at a few equations going from rectangular to polar and polar to rectangular and so on and so forth. So, what mode is this currently in?
Rectangular.
Wow, you guys are so good. All right. We want to go into polar. And again, we just have to find a way to get some polar stuff in here. Well, do we know what x and y are?
No.
Think about those four equations. Do we have a formula for x?
Yes.
What is it?
R cosine theta.
R cosine theta. Good. So let's plug it in. Plus 5. And do we have a formula for y?
R sine theta.
Good. Okay, so while this is technically now a polar equation, what we want to do is try to get r alone, if possible. Sometimes I'll let you keep it as, like if there's a square. If it makes sense to leave it as r squared, we'll do that too. But we can get r alone pretty easy here. Both of these terms have what in common?
Theta.
Well, that. What else?
R.
An r, the radius. Let's pull that out. And then what's left? 3. Good. So if we factor out r, this is what's left. And if we're trying to get r alone, what's the last thing we do? Divide. Good. So 15 over 3 cosine theta plus 5 sine theta. And we're done. That's the answer. This is now the polar equation equivalent of the rectangular equation, which is a line. Both of these will be a line. If you were to graph this on your calculator in function mode, you get the line. If you graph this in polar, you'll get the exact same picture. Okay? Now, this really not much cleaner or nicer compared to this one. Okay, but one of the points I hit yesterday was that in calc, a lot of times converting from rectangular to polar makes life easy. Okay, let's look at a different example and you'll see what I mean. So here's another, what kind of equation? Rectangular. We're going to go into polar. Same idea. I don't know x squared, but I can plug in a formula for it, which is, again, what? Same as this one.
R cos theta.
Yeah, don't make it harder than it is. So 4, and we're just going to plug in r cosine theta, but we're going to square it, and then this will be 4 r sine theta squared equals 16. So far, so good? Okay. So then we have 4. This is two things being multiplied together. We got to square them both. So 4 r squared and cosine squared. And then plus 4 r squared sine squared. Think along the lines of the last problem. Can we factor anything out? Very good. And now what's left? Cosine squared plus sine squared. Yes, it does. This part equals 1. Whoop, dropped a 6 back there. Nobody saw that. It's okay. So we get 4r squared equals 16. What else can we do? Divide by 4 and square root it. We get...
2.
Oh, I didn't divide by 4 yet. Sorry. Good catch. So r is 2. Okay? So, perfect example. this equation versus this one. Which one seems nicer?
The second one.
The second one, okay? And when you do calc stuff, this will be a lot easier to handle than having all these squares and stuff in there. Okay, so that's one of the skills. Being able to go back and forth is going to be useful down the road. Let's go the other direction. Because we've done rectangular to polar, another rectangular to polar. Anybody still need this? Are we good? Question? Good question. You don't need plus or minus 2. And you'll know why when we start doing the graphs, but this just means that we are 2 units away from the pole, from the center. So, you know, if you pick any angle and go out 2 or back 2, plus or minus, it's redundant because you're going to hit everything. So whether you do r equals 2 or r equals negative 2 or r equals plus or minus 2, you get the same exact shape. In fact, if you want to check real quick on your calculators, you know how it's... Oh, I haven't even shown you this yet. We can do a quick sneak peek. Go to your mode setting. This is what we're going to do tomorrow, but might as well talk about it real quick. We said that there's a function mode, a parametric mode. What's the next one?
Polar.
Polar mode. Switch it over to polar.
How do I get that?
Go to mode.
Oh, found it.
Everybody see it? And now, when you go to y, it doesn't matter. When you go to y equals, now you don't see y or x, you see r. Press the variable button. Now you get a theta to pop in there. And if you mess around, you get some pretty neat graphs. But here's what I was trying to say earlier. Type in just r equals 2 and graph it. What do you get?
Nothing.
You should get something.
No, I got nothing.
Ellipse. Circle.
Here, borrow a calculator real quick.
Here, there. I got nothing. I don't see anything. I don't like it.
Put it on the camera.
What?
So when you're in polar mode, type in 2. You get what seemingly looks like an ellipse. Let's make it look better. If you do zoom square, it actually makes the dimensions of your viewing rectangle what they should be. What does that look like? Circle. Okay. If you do r equals negative 2, doesn't change. It's the same shape. Okay. If you don't believe me, delete the 2. Okay. Just graphs it a little different, but it's still the same shape. Okay. Yes. Why what?
Yeah, nothing appears.
Do zoom 6 first.
Oh.
And now do zoom square. Okay. Did anybody mess around with some other stuff? Like this one? This. You can't really... Oh, let's zoom back in. It is a spiral. And
What's a spiral?
if I change my window so that my angle goes not only to 360, yeah. We'll talk about some of these shapes tomorrow. Anyway, here you go. Ugh. All right, let's finish this up. Last 2. Anyway, does that kind of help answer your plus or minus? You can have it. I'll count it. Same thing, though. So let's say you have r equals cosine theta minus sine theta. This is obviously in polar. So we're going to go to rectangular mode. Okay, this is a little different. It's not hard, but it's just a little weird how we have to get there. We know what x looks like, right? What's the formula for x? R cosine theta. What's the formula for y? R sine theta. Well, this is almost x, and that's almost y. What's missing? It's missing an r. So, why not? Yeah, let's multiply by r. Let's see what happens. R times r? R squared. R times cosine is r cosine theta, and then r times sine theta is r sine theta. And now let's see if we can get our formulas in here. Do we have a formula for r squared?
Yes.
X squared.
X squared plus y squared.
Good. And what's r cosine theta? What's r sine theta? Okay, and just so everybody's on the same page, I'm going to ask you guys to always set these equal to 0. So we're just going to move everything to one side. X squared plus y squared minus x plus y. And there you are. That's it. Questions on how we did that?
No.
Everyone knows why we multiplied by r? Okay. Let's see what happens with this last one. R equals cosine 2 theta.
Don't you convert that into like sine theta to double to cosine theta, something like that?
Forgot the formula, but you're right. You have to convert this. What's the double angle formula for cosine 2 theta? Good job. We don't have any formulas in that link 2 theta, right, with x and y, so that's not good. But we do know that cosine 2 theta is cosine squared theta minus sine squared theta. So now we're looking a little better. This is going to become what, do you think? X. But cosine is squared. So it's really going to turn into an x squared. Does that make sense? This is a sine squared, so what do you think that's going to turn into? Y squared. Good. What's missing, though?
Multiply by r.
If I multiply by r, I don't quite get there. And I can show you again. X squared was actually r squared cosine squared, right? And y squared was actually r squared sine squared. And I think some of you caught on right away that it's not r we multiply by, but r squared. So let's see what happens there. Multiply by r squared, we get what?
R cubed.
R cubed. Good. Equals r squared cosine squared minus r squared sine squared. I'm going to leave this alone for a minute because we don't have a formula for r cubed, right? But what's this term now?
X squared.
X squared minus y squared. You know, in the last example, we had an r squared and everybody was happy. Well, maybe you weren't happy, but we'll pretend that you were. Because it just turned into x squared plus y squared really easily, right?
Oh.
So, what do we really wish this was instead of r cubed? Let's make it r squared.
What?
All right.
Why defense is equal? I lost.
I like the reaction. What? You can't do that. You're right, I can't. Unless I adjust the exponent on the outside of this. It's a nifty little trick. 2 to what power, or I'm sorry, r squared to what power turns it into a 3. What do you do with exponents when you got them on the outside?
Add. You multiply.
Multiply.
Multiply and add.
So, what number can I stick out here so that when I multiply 2 with this,
1.
I get 3? You were adding. 2 plus 1 is 3. We want to multiply. Here's what we really just did, guys. Let me re-ask the question. 2 times what number equals, we wanted it to equal what? 3. How do I solve for question mark? If I'm multiplying, divide by 2. Does that make sense? Okay. So now, even though this looks kind of weird, I do have r squared, which we know is x squared plus y squared. That's going to stay to the 3 halves. And we'll move everything to the left-hand side just like the other one. So minus x squared plus y squared equal to 0. And now we have everything with x's and y's. We're on rectangular. We're good. What's that?
Oh, he made it really big.
Yeah.
Oh, I couldn't see from over here. All right. Are there any questions on this?
That's your answer?
That's the answer. You can leave the goofy exponent. This is a rectangular equation.
Can you give us like a test question, like a kind of test question? Because like you give these examples and they're like super easy, and then I get to the test. And it's like, what am I learning? Like,
That's not at all how it works.
Yeah.